So let's draw our cheat sheet. I'm going to put this guy on here too. All seniors take calculus. We won't be using this a whole lot today, particularly because in today's topic, we want to apply these right triangle trigonometry that we were working with on Wednesday, namely this notion of reference angles. We're going to apply it to real world situations. In real world situations, the triangles, we essentially always consider the side lengths as positive. So there's no like fancy positives and negatives that can come about when we're in different quadrants. Let's go ahead and label the sides. I'm going to use degrees today since a lot of the problems we're going to be doing is in degrees. But they could just as well be in radians. And let's see, anything else we want to put on there? So I don't want to write the trig functions. Maybe the Pythagorean theorem. It's always a good one. Even that one, though, I don't think most people need to memorize or need to write down since it's already memorized. And then in the coming days, coming weeks, we'll have some trig identities, which we'll get started with on Monday. So this is our reference sheet. And so our question now is, how do we use this information? If we were given some initial data in a context, can we solve for other side lengths in a triangle? So for example, let's suppose you are standing a distance away. This distance is going to look weird. 500 squared or 3 divided by 3 feet away from the Washington Monument. And the angle of elevation is 60 degrees. Question is, how high or how tall is the monument? So let's draw a picture. It's not a good picture. I want to draw it to scale. So we're given one angle. So the angle of elevation is the angle that is made with the horizontal. So we had a 60-degree elevation, and we are given that our distance away is 500 squared to 3 divided by 3. What do we want to find? We want to find the height. So some things you can always do to set up your word problems. Once you've drawn a picture, sometimes it's nice to write down things you are given. We're given an angle, and then we are also given the adjacent side relative to that angle. And what do we want to find? Almost always the last sentence in any sort of word problem is the question, is what we want to find, what they want you to solve for. How high is the monument? And we labeled it as y relative to the angle given. It's the opposite side. So you have to look at the information given and the information you want and essentially come up with an equation that relates those three things. We need an equation that relates a given angle, an adjacent side, and the opposite side. So the function that does that is the tangent function. So relative to this triangle, we have the equation that tangent of 60 degrees is equal to y divided by 500 squared of 3 over 3. So tangent of 60, we want to be able to evaluate. And how do we evaluate it? We go back to our reference sheet here. We have a 60-degree angle. So what is the tangent of 60 degrees going to be? It's going to be square root of 3 divided by 1. So we can evaluate this guy and get the equation square root of 3 over 1 if you want to write it. Let's go ahead and simplify this since it's a fraction within a fraction. It's going to be 3y over 500 square root of 3. So I just multiply by the reciprocal of that denominator. And now all we got to do is solve for y. So y is going to equal 500 root 3 times square root of 3, and then divided by 3. Square root of 3 times square root of 3 gives me 3. And so y we get was 500 feet. Other things that we can do is sometimes the problem statements will be something like solve a triangle. Let's say we've got something like and the problem says solve the triangle. Solving the triangle just means you want to find all the side lengths and all of the angles. So all the information about the triangle. We're given two sides. Let's go ahead and label the third side. And let's label the angles too. Let's say alpha and beta. So we are given two sides. And of course, what do we want? The angles and the third side. So the angles at the moment are going to be a little tricky just because we don't know inverse trig. But to kind of get you thinking along those lines, we'll solve for it in this problem. So actually go ahead and start off with the third side. So why do I want to start off with the third side? We have a right triangle. And in our cheat sheet, we've got all of our trig functions. So trig functions relate an angle to a ratio of side lengths. But since we're not given any angles, we don't want to use a trig function. Instead of given two sides and want to find the third, which means the Pythagorean theorem is going to be a good tool to use here. So the Pythagorean theorem says that 5 squared plus x squared equals 10 squared. And we need to solve for x. So 10 squared is 100, 5 squared 25, x squared is going to be 75. And so x is square root of 75. We can redraw the triangle if we want, but now we got to find the angles. And the best way to find the angles is they have to be known angles, angles that we like to work with. Namely, it has to be one of these two triangles. Or it could be a degenerate triangle, like a 0 degree or a 90-degree angle. But of course, in this case, since we have an actual triangle, it's going to have to be one of these two. We just have to just figure out which one's which and which angles get assigned where. So one thing we want to do, square root of 75, let's go ahead and simplify. That is square root of 25 times 3, which is going to give us 5 square root of 3. And so now what we want to do is recognize that what are the ratios of the sides? So for example, if we wanted to find alpha, this tells me that the sine of alpha is 1/2. The cosine of alpha is, we'll simplify it, 5 squared to 3 over 10. So square root of 3 over 2. And so what you want to ask is what angle has these trig values. You can compute tangent if you want, but I think we were kind of talking a little bit about on Wednesday about how sine and cosine are essentially the building blocks for all the other trig functions. I can always just take the ratio, sine over cosine gives us tangent. So once you have those two, it should give you enough information. So what you want to do is look back at your reference triangles and say, which angle, when I compute sine, do I get 1/2? Hopefully you see it's this 30 degrees here. Sine of 30 degrees gives me 1/2. Cosine of 30 degrees gives me square root of 3 over 2. Whereas any of the other angles, sine of 45, 1 divided by square root of 2, that's not going to work. Sine of 60 gives me square root of 3 over 2. Cosine of 60 gives me 1/2. But just be careful with that, right? Since those aren't flipped, we need the sine ratio of the angle to be 1/2. And so by recognizing the ratios of the sides, we can essentially conclude that alpha is 30 degrees and beta then is equal to 60 degrees. So if you wanted to draw the complete triangle, it would be this. So that's briefly how you use these trig triangles, these reference triangles. Kind of like what we were doing yesterday. Yesterday we were applying these reference triangles in reference angles, finding reference angles for angles that might be bigger than 90, bigger than 180 degrees. Now we want to refer to these triangles to compute ratios of sides, solve for unknown sides, and use those along with the Pythagorean theorem to solve for triangles. Let's do one more that's going to be a little bit more involved. So this example is going to be a little tricky because there's going to be a lot more. Let's say we're standing 2 kilometers away from a radar station. And the radar station picks up an airplane at 45 degrees to the west now. In other words, this angle here is 135 degrees. There's our airplane. And we're also told that the angle of elevation between us and the airplane is 30 degrees. And the question asks, how high is the plane? We can actually have 2 questions. Let's say, how high is the plane? We'll call that question 1. Question 2, how far away is the plane? And I don't know if we'll have time to answer that second question, but we can talk about how to go about it. I'll see if you guys can do it on your own. So what do we do in this case? Notice that we do not have a right triangle. So I've already kind of drawn a little bit of what's going on. Since the ground continues, we can essentially force a right triangle into the drawing. We're given angles and we're also given at least part of one side. Question is, how do we solve for the rest? So this is where we need to do some work. We can solve for the rest of the information in the triangle to see whether or not it will help us. So first of all, one of the things you guys should know is there are 180 degrees in every triangle. You take that as given. You assume that you guys learned that somewhere in high school. If you didn't, now you know. So what are the sum of the degree angles? We have 135 plus 30 is 165, meaning that this angle here, the short one, is 15 degrees. I know I have a right angle between the vertical side and the ground. We're asked to find the height. The altitude of the plane. So let's give that a variable. Let's call that y. And now what else can we solve for? So I don't know this piece here yet. So how can I solve for y? And if you get stuck in a problem like this, sometimes it helps to maybe go backwards a little bit. Well, I'm given part of this side length, and I have this angle here. It's a 30-degree angle. We like 30-degree angles. It's one of our reference triangles. Well, relative to this 30 degrees, I want to find the opposite side, and I'm given at least some information about the adjacent side. Let's call this side x for the moment. So we at least know that sine of 30 degrees, or excuse me, tangent 30 degrees is y over x. Y over x plus 2, since this entire side length is 2 plus x. So if I know x, we can then solve for y. Okay. So how else can we get information about x? Look for perhaps different triangles. We have a 30, 60, 90 triangle and this bigger outer triangle. What about this inner triangle here? What are the degree angles in this case? Well, this angle is 135, which means I can find the supplementary angle here. So this angle here actually has to be a 45-degree side, because halfway around the circle is 180. And if that side's 45 degrees, that means this side is 45 degrees. And if both of the angles are 45 degrees, that means that the side lengths are the same. It's an isosceles right triangle. It carries the same ratios as our reference triangles. So in a 45, 45, 90 degree triangle, side lengths are 1, 1, square root of 2, at least in the ratios. We can scale this and stretch it, but it's still going to maintain the same shape. Namely, the two side lengths are equal. And so that helps us. If x equals y, we now have the equation tangent of 30 degrees equals y over y plus 2. So we got rid of those x's. Now I just have one equation with y's in it, and we can solve for y. So let's fill in our known values. What's tangent of 30 degrees? That's our reference triangle. Tangent of 30 degrees is 1 divided by square root of 3. And now all that's left is to solve for y. So we'll have 1 over square root of 3 times y plus 2 equals y. Let's just multiply that square root of 3 over. Square root of 3y. Square root of 3 is bigger than 1. So let's say 2 is equal to square root of 3y minus y. Square root of 3 minus 1 times y is equal to 2. And so our y is equal to 2 divided by square root of 3 minus 1. So whatever that ends up being, again, square root of 3 is probably about 1.6, 1.7 or something like that. So minus 1 is going to be 2 divided by 0.6. So something slightly bigger than 2 for y. If you want to compute that to get an estimate in a calculator, go for it. Please, please, please do not use calculators on the quizzes, though. Okay, so I guess our last question, maybe we can answer it real quick. How high is the plane? That high. That's our y value. How far away is the plane? So that's this distance from us standing here all the way to the plane. We want to find r. How do I find r in this case? Well, I have a 30-degree angle. I have y. I know that sine of 30 degrees is y over r. And sine of 30 degrees we can evaluate as 1/2. So we would multiply the r over, multiply the 2. R is 2y. So r is going to be 2 times 2 over square root of 3 minus 1. Or 4 over square root of 3 minus 1. Sorry if that wasn't on the video there. Any questions?